Hello and welcome to our first video for DMA 30 section 3.2. Today we're going to start our discussion on proportions. In this video we'll cover the definition of proportions, we'll look into cross products, and then we'll determine if two proportions are equal. Next, in the next video we'll look at solving proportions for an unknown variable, and then we'll look at some proportion applications. Let's start with a definition. A proportion is defined as a statement where two ratios or rates are equal. So let's look at this first example here. Here we have a ratio, units are equal and canceled out, of 1/2 equals 3/6. And this is a true proportion. One ratio is equal to another ratio. We know that these two ratios are equal because they have a common factor of 3. If I did 1 times 3 and 2 times 3, I multiply the numerator and the denominator by the same number, I'll get 3/6. So we know for a fact that these are equal. In our second example, we have rates, because the units here are different, waiters to tables. 3 waiters to 7 tables is equal to 9 waiters to 21 tables. And this is true as well because we have a common factor of 3. We can multiply this by 3 and multiply this by 3 to get 9/21. So we have two equal rates here, so these are proportional. So try and think of proportions like scales. We want them to be balanced. We want them to be equal on both sides, so one side isn't heavier or greater than the other. Now let's look at cross products. A cross product is when we multiply two diagonal terms of a proportion together. The book defines these as the, right here, the means and the extremes. So we would call these, right here, these two numbers diagonal from each other, the means of this proportion. And these two diagonal terms we'll call the extremes. Okay, I just wanted to show you those terms because you will see them in your homework for this section, but we won't use those too often when we talk about cross products and proportions in this class. So cross products should always be equal to one another for true proportions. So let's find the cross product of the means here. If we cross multiply the 5 times 16, that's our first cross product, the means, we get 80. And if we find the second cross product here, 4 times 20, we get 80 as well. So we know that this is a true proportion. So for a proportion to be true, their cross products, or the means and the extremes, the products of the means and the products of extremes, should be equal. And in this case, they certainly are. So to reiterate what I just said, if we want to determine if a proportion is equal, we first multiply along the diagonals, find the cross products, and then multiply along the other diagonal. If these cross products are equal, then the proportion is true. If these cross products are not equal, then the proportion is false. So next we're going to look at a couple cases where we'll determine whether or not a proportion is true or false. So let's determine if these following proportions are true. The first one, we have 12/8 equals 9/6. And let's take the cross products and set them equal to each other. The first is 8 times 9. And if this is true, it should equal the other cross product, 12 times 6. Alright, let's multiply both sides and see if these are true. 8 times 9 is 72, and 12 times 6 is also 72. So these cross products are equal. This proportion is true. Okay. Let's look at the second proportion. 7/24 equals 2/7. Alright, our first cross product is 24 times 2. And if this is true, it should equal the second cross product, 7 times 7. Okay, 24 times 2 is 48. And And does that equal 7 times 7? Well, 7 times 7 is 49. So these cross products are not equal. Okay, so since we determined that those two cross products aren't equal, that means that this proportion is going to be false. Alright, now let's look at some examples where we don't have whole numbers for our numbers on our proportions. As we'll see in this first example, we've got decimals. So, this first cross product here is 0.6 times 2.4. And that should equal the second cross product, 0.9 times 1.5. Alright, so I'm going to do a little bit of cheating here, since in DMA 30 we're allowed to use a calculator, so I guess it's not really cheating since we're allowed to. Let's find these cross products. 0.6 times 2.4 is going to equal 1.44. Does that equal the second cross product? Our second cross product is 0.9 times 1.5, and that equals 1.35. So these cross products are not equal. This proportion is going to be false. In our second example, we have mixed numbers. Alright, so the first cross product will have 3.5 times 4 2/3. And that's going to equal the second cross product, 2 1/3 times 7. Alright, since we're multiplying fractions, or mixed numbers, we need to change these into improper fractions first. So 3.5 is going to be 7/2. We multiply the denominator by the whole, and then add that. So 3 times 2 is 6, plus 1 is 7, and then keep the same denominator. Here, 3 times 4 is 12, plus 2 is 14, so we'll have 14/3 equals 2 times 3 plus 1 is 7/3. And I'm going to write 7 as 7 over 1. Alright, we'll multiply across the top here, and we'll get 7 times 14 is 98 over 2 times 3 is 6, and over here 7 times 7 is 49 over 3. And I'm going to go ahead and divide those out. So 98 divided by 6 is going to be 16.3 repeating. I'm going to write this over here, 16.3 repeating. And is that equal to the second? 49 divided by 3 is also 16.3 repeating. So these cross products are equal. This proportion is true. So to review, in this video we covered the definition of proportions. We looked at the cross products, or means and extremes of a proportion, and then we determined if proportions are equal by finding their cross products. In the next video we're going to look at solving proportions for an unknown variable, and then look at some applications. See you next time.